Welcome to the Agrahood. Carnes Crossroads is a new home community with a farm-to-table lifestyle. Just outside of Charleston, here, community is defined by gathering together and our deep connection to nature.
Learn more at carnescrossroads.com.
This is SpaceTime Series 20 for episode 143 for broadcast on the 27th of December 2021. Coming up on SpaceTime, the James Webb Space Telescope launches into space, NASA touches the Sun, and Europe's ExoMars orbiter discovers water hidden in the red planet's version of the Grand Canyon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The James Webb Space Telescope has been successfully launched into orbit aboard an Ariane 5 rocket. The $10 billion successor to Hubble was launched from the European Space Agency's Kourou Space Centre in French Guiana into a highly elliptical orbit that will eventually see it positioned 1.5 million kilometres away in what's known as the Lagrangian L2 position, a sort of gravitational well that will always keep the James Webb on the opposite side of the Earth from the Sun.
The weather is go. We have a green board, no issues being worked. NASA officials carefully watching the telemetry, looking intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly. The DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2-minute mark in the countdown.
The flight will be in two phases. During the solid rocket boosters phase, that will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by a to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
Thumbs up from Jean-Luc Voyer. All systems are go. We're inside a minute now. T-minus 50 seconds and counting. The Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way. T-minus 30 seconds and counting. Standing by for terminal count.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start and liftoff.
Décollage.
Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. Rumble of the powerful Ariane 5 now being felt here in the control center.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah. Impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling 0.6 kilometers per second.
Les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the Range Operations Manager. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters, coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration for
Tous les paramètres à bord sont normaux.
Everything is okay. Everything is normal.
2 minutes, 15 seconds into the flight.
When the computer detects this threshold, it will separate.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer. This coming at an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. Fairing jettison, that'll be the next critical milestone.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to be protected. So each kilogram being very important for the performance of the launch, we are going to eject this no more useful fairing.
And let's go down to the floor in the Jupiter Control Center to Raphael Chevrier of Arianespace. Raphael, so far so good.
Hi, Rob. So far so good. Everything is nominal, as we say when attitude and trajectory of the Ariane 5 is going perfectly well. We had the confirmation of the separation of the two solid boosters and now of the flaring, meaning that we have crossed the limits of the atmosphere. So everything is going super good. And the DDO just said that all parameters are going perfectly smoothly.
La trajectoire est nominale.
Trajectory is nominal. The report from Jean-Luc Voyer. The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Flight control is very smooth.
We have about 3.5 minutes to go in main stage or first stage performance. Right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
Telemetry data are now received by the Galileo tracking station, which is close to here, where we are in Kourou. It will track the launcher to the ignition of its upper stage. And then we'll have the natal station in Brazil, Ascension in the middle of the ocean, and the two last stations in Africa, Libreville and Malindi, one on the east coast, the other one on the west coast. And the one on the west coast, Malindi, the telescope will be separated more or less over this Malindi station. And this Malindi station will also acquire the telemetry data from the telescope. Both are green. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de télémesure par la station du Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data relay satellite system. As it moves further and further out into deep space, all of the telescope's telemetry and its imagery ultimately will be processed through the Deep Space Network in Goldstone, California. We passed the 7-minute mark into the flight. A perfect ride so far on the Ariane 5. We have about 1.5 minutes to go in the first stage performance. Once the main stage engine is commanded to cut off, it will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit. About 11 minutes from now, telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array and the initiation of generation of electrical power for the telescope. About 30 seconds away from main engine cutoff.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the range operations manager as we stand by for main engine shutdown and separation.
Extinction de l'EPC. Préparation EPC.
And we have main stage shutdown and separation confirmed here in the Mission Control Center, and the ignition of that upper stage. And Raphael Chevrier down in the fishbowl. So far, so good.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
And a short time from now, the so-called sawtooth maneuver will get underway. Again, like rocking a baby in a cradle, this will be a maneuver to keep Webb's optics protected from overheating.
A number of exhaustive studies have been performed by the mission teams in Europe, in the US, on the thermal conditioning inside the telescope and the way the rays of the sun would propagate and interact with sensitive equipment inside the telescope. Maintain this thermal conditioning is really key before separating this telescope. And in particular, we know that one face of the telescope cannot face the sun. That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach, and the upper stage is going 30 degrees on one side, then 30 degrees on the other side, going back and forth this way to maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion coming up on the 12-minute mark into the flight, the telescope controllers will be taking the baton, if you will, from the mission controllers here in Kourou. The first steps will be the opening of fuel valves, a pair of fuel valves, to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array. That call will come from the mission operations manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft deployed radiator will be released to prevent binding due to the cool down of the telescope's composite structure. The contamination control heaters will be enabled to protect instrument optics on Webb from any water-ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water-ice condensation, later to be used to position each of the mirror's segments. All 6 reaction wheels and the wheel drive electronics will be powered on for Webb, and that will be the precursor to the attitude control system using those reaction wheels to maintain the proper orientation with the sun, as opposed to using onboard thrusters. Of course, fuel in those thrusters, very valuable. It's a limited commodity for the lifetime of James Webb's observations of the universe. James Webb, of course, will be traveling well beyond the moon to a distance of about 1 million miles away from Earth, settling into a highly elliptical, halo-like orbit to begin its astronomical observations. And again, as we mentioned earlier, at the time of observatory separation, Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour.
We'll have a short ballistic phase, a short coasting phase that will, when the upper stage will rely fully on its what we call the attitude and roll control system, and it will adjust its attitude so that during this so small ballistic phase, all the requirements from the telescope are fully met, and that at the separation, when there will be the separation, the conditions will be very smooth and as requested for the telescope. Beginning of flight.
22 minutes into the flight, less than 3 minutes of powered flight remaining.
Smooth flight control.
And again, as we've mentioned before, everything nominal reported by the range operations manager. As we've mentioned before, this is a long ride uphill for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight and the separation of the telescope.
And we're standing by for upper stage shutdown and the cutoff of the upper stage engine.
Extinction ESC. Tous les paramètres à bord sont normaux.
The extinction of the shut-off of the cutoff of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase that will last for a little more than 2 minutes.
And the telescope controllers in Baltimore confirming that all of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
Séparation Webb Space Telescope. Go Webb!
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery. It was a perfect ride to orbit, and all of the separation sequence events are running in good fashion according to the telescope controllers. The James Webb Space Telescope, as it moves gently away from its launch vehicle. Ironically enough, as we marvel on this view from the upper stage camera, this will be humanity's last view of the James Webb Space Telescope as it moves to its workplace about 1 million miles away from Earth. A bit earlier than planned, but there is the solar array having been deployed. James Webb now has its array out as we stand by for a confirmation that it is power positive. And there it is. There's your critical call. James Webb not only has legs, but it has power as it begins its journey and the commissioning activities to follow.
It'll take a month to reach its eventual perch, which is 4 times further away than the Moon, and another 5 months to begin science operations. That's assuming the complicated process of unfurling the giant observatory proceeds as planned. If all goes well, the wispy 5-layered sun shield will begin opening 3 days after liftoff. It'll take at least 5 days to unfurl and lock into place. Then on day 12, the octagonal gold mirror segments will be opened up and locked in. The origami-like process of setting up the telescope in orbit will take many weeks, with hundreds of release mechanisms needing to operate exactly as planned for the 7-ton observatory to expand to its full 21 by 14 metre operational size. Because of its distance from Earth, if something goes wrong during this process, NASA won't be able to send astronauts out on a repair mission as they did with Hubble when it was launched aboard the Space Shuttle Discovery in 1990. So, everything's going to need to work first time round. Once operational, James Webb's 6.5 metre gold mirror will see further back into the universe than any other telescope ever built. It'll provide astronomers with wondrous views that'll change science's understanding of the cosmos. Hubble could see back almost 13.4 billion years. James Webb will go back even further, taking science closer to the dawn of time than ever before. Unlike Hubble, James Webb will look through infrared eyes to see the light coming from the very first stars. And that light will have been stretched by the physical expansion of space-time from the ultraviolet and visible into infrared wavelengths. But like Hubble before it, James Webb will change the way we see the universe forever, peering back to the birth of galaxies and analysing the atmospheres of distant worlds in the search for life. This report from NASA TV.
NASA's James Webb Space Telescope is preparing to begin its mission of discovery. By observing infrared light, Webb will be able to look through dust to see stars forming inside of nebulae. It will also allow scientists to observe farther back in time than previous telescopes. More distant objects in the cosmos are more highly redshifted. That means their light shifts from ultraviolet and visible wavelengths into the near infrared. This shift in wavelength means observations of distant objects, such as the first galaxies that formed in the universe, require a telescope specialized in collecting infrared light. While Webb will explore the cosmos in infrared light, Hubble will continue its observations of the universe in visible and ultraviolet wavelengths. Since 1990, Hubble has completely changed our understanding of just about everything. From galaxy evolution to gravitational lensing and dark matter, from exoplanet atmospheres to our own solar system, Hubble continues to teach us something new about our place in the cosmos. The scientific community is incredibly excited to have these two highly complementary observatories operating together. With their collaboration, they will push the boundaries of knowledge on the backdrop of a rapidly evolving astronomical landscape. A wealth of multi-wavelength and now multi-messenger astrophysical observatories from space and from the ground are currently operating or being planned. Hubble and Webb will work together to advance our collective understanding of the universe, ushering in a new golden age of astronomy.
This is SpaceTime. Still to come, NASA touches the Sun, a giant asteroid the size of the Eiffel Tower, and Europe's ExoMars orbiter discovers water hidden in the red planet's version of the Grand Canyon. All that and more still to come on SpaceTime. For the first time in history, a spacecraft has touched the Sun. The honour went to NASA's Parker Solar Probe, which reached the Sun's extended solar atmosphere known as the corona, spending 5 hours there. The findings, reported in the journal Physical Review Letters, marks the achievement of the mission's primary objective and also opens up a new era in science's understanding of the physics of the corona. You see, these are the first direct observations of what lies within the Sun's atmosphere, actually measuring phenomena previously only estimated. The Sun's outer edge, for want of a better term, begins at what's known as the Alfvén critical surface, the point below which the Sun and its gravitational and magnetic forces directly control the solar wind, the constant stream of charged particles flowing out from the Sun. Many scientists believe that sudden reversals in the Sun's magnetic field known as switchbacks emerge from this area. The idea of sending a spacecraft into this magnetic atmosphere, where the magnetic energy is greater than both the ion and electron kinetic and thermal energy, has been a dream of science since before the very creation of NASA. But it wasn't until 2018 that human technology reached the stage of being able to launch such a mission. And so the Parker Solar Probe finally blasted off with the goal of reaching the Sun's corona and undertaking what's been humanity's first visit to a star. The 5 hours the Parker Solar Probe spent below the Alfvén critical surface in direct contact with the Sun's plasma allowed it to collect observations on the pressure and energy of the Sun's magnetic field. Parker passed above and below this surface 3 separate times during its encounter. Surprisingly, astronomers found this Alfvén critical surface is wrinkled. The data suggests that the largest and most distant wrinkle on the surface was produced by what's known as a pseudostreamer, a large magnetic structure more than 40 degrees across, found back on the innermost visible face of the Sun. Scientists still don't know why a pseudostreamer would push the Alfvén critical surface away from the Sun, but researchers did notice fewer switchbacks below the Alfvén critical surface than above it. The findings could mean that switchbacks don't form in the corona but deeper down. Alternatively, lower rates of magnetic reconnection on the Sun's surface could have pumped less mass into the observed wind stream, resulting in fewer switchbacks. The probe also recorded some evidence of a potential power boost just inside the corona, which may point to some unknown physics affecting heating and dissipation. The Parker Solar Probe is now the fastest known object ever built by humans, and it's made many new discoveries since its launch, including observations on explosions that create space weather and the dangers of super-speedy dust. Having achieved its primary goal of touching the Sun, Parker will now descend even deeper into the Sun's atmosphere and linger for even longer periods of time. This report from NASA TV.
Liftoff of the mighty Delta IV Heavy rocket.
In August 2018 in Cape Canaveral, Florida, NASA launched Parker Solar Probe to touch the Sun. After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the Sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the Sun? To answer that, we need to look at the Sun's structure. Unlike Earth, the Sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as solar wind.
The boundary that marks the edge of the sun's atmosphere is known as the Alphane critical surface.
We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how our star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the Sun, the spacecraft was around 20 solar radii, or 8 million miles from the Sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away
at high speeds so that it can't return back to the sun's surface.
Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun.
As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface.
Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.
This is SpaceTime. Still to come, a giant asteroid the size of the Eiffel Tower has just zoomed past the Earth, and astronomers have found significant amounts of water hidden in the red planet's massive Valles Marineris canyon system. All that and more still to come on SpaceTime. An asteroid the size of the Eiffel Tower has just zoomed past the Earth. Asteroid 4660 Nereus sped past our planet at around 24,000 kilometres per hour, but at a relatively comfortable distance of 3.9 million kilometres. Still, it's officially classified as being potentially hazardous. You see, any asteroid that passes within 7.5 million kilometres of Earth is potentially hazardous. That's because it would only take a small change in its orbit to turn a near miss into a direct hit. In 39 years from now, 4660 Nereus will make a far closer approach to the Earth when it swoops past our planet at a distance of just 1.2 million kilometres, a veritable hair's breadth in astronomical terms. And of course, it's not alone out there. The European Space Agency says there are currently some 27,566 asteroids and 117 comets, which are all classified as being near-Earth objects. This is SpaceTime. Still to come. Europe's ExoMars Trace Gas Orbiter discovers water hidden in the red planet's Grand Canyon. And Arianespace launches 2 more European Galileo navigation satellites. All that and more still to come on SpaceTime. Astronomers have found significant amounts of water hidden in the red planet's massive Valles Marineris canyon system. Located near the Martian equator just east of the Tharsis region, the dramatic Valles Marineris appears to be a huge split in the planet's surface. The complex system of deep ravines, valleys and canyons stretches for over 4,000 kilometres and is up to 7 kilometres deep. That's some 10 times longer and 5 times deeper than America's famous Grand Canyon in Arizona. The new data from the joint European Space Agency Roscosmos Trace Gas Orbiter spacecraft suggests large amounts of water in the very heart of the canyon system. The water, which is hidden beneath the Martian surface, was detected in hydrogen mapping operations in the uppermost metre of the soil. While water is known to exist on Mars, most of it is found in the planet's cold polar regions as ice. Water ice is simply not found exposed at the surface near the equator, where temperatures aren't cold enough for exposed water ice to remain stable. Missions including ESA's Mars Express have searched the lower latitudes looking for subsurface water, mostly as permafrost or locked up in minerals, and they've found small pockets of it. But the new observations suggest an area with an unusually large amount of hydrogen in the Valles Marineris. And assuming the hydrogen is bound up into water molecules, as much as 40% of the near-surface material in the canyon appears to be water. Put that another way, there's enough water there to make a lake the size of the Netherlands. The authors think it's very much like Earth's permafrost regions, where water ice permanently persists under dry soil because of the constant low temperatures. Now, the water could be in the form of ice, or water that's chemically bound to other minerals in the soil. However, other observations suggest that minerals commonly seen in this part of Mars typically only contain a few percent water, much less than what's evidenced in these new observations. And all that suggests the new findings could be in the form of water ice. But water ice usually evaporates in this region of Mars due to the temperature and pressure conditions near the equator. And the same applies to chemically bound water in the soil. So, the right combination of temperature, pressure and hydration must be there in order to keep the minerals there from losing water. This suggests that some special, as yet unclear mix of conditions must be present in Valles Marineris in order to preserve the water. Either that or it's somehow being replenished as it sublimates into the air. As most future missions to Mars plan on landing near the lower latitudes, locating such a reservoir of water here is an exciting prospect for future exploration. While Mars Express has found hints of water deep underground in Mars's mid-latitudes, alongside the deep pools of water under the planet's south pole, these lie up to several kilometres below the surface, making them less exploitable and consequently less accessible for exploration compared to water found just below the surface. ESA's ExoMars Trace Gas Orbiter project scientist Colin Wilson says knowing more about how and where water exists on present-day Mars is essential to understanding what happened to the red planet's once abundant water supplies. He says it helps in the search for once habitable environments which today could possibly still hold signs of past life. Mars Trace Gas Orbiter was launched back in 2016 as the first part of the two-part ExoMars mission. The orbiter will be joined next year by a Russian surface platform and a European rover, the Rosalind Franklin, which will search for signs of life on the red planet. That mission was to fly in 2020, but was delayed because of the COVID-19 pandemic. This is SpaceTime. Still to come, Arianespace launches 2 more European Galileo navigation satellites into orbit. And later in the science report, a new Arctic record temperature of 38 degrees Celsius. That's more than 100 on the old scale. All that and more still to come on SpaceTime. Arianespace have launched 2 more European Galileo navigation satellites into orbit using a Russian Soyuz rocket. The flight from the European Space Agency's Kourou spaceport in French Guiana brings the Galileo constellation to 28 satellites. The twin 715-kilogram spacecraft were released from their Soyuz STB frigate upper stage at an altitude of 23,525 kilometers, 3 hours and 54 minutes after liftoff. Galileo is already the world's most precise satellite navigation system, serving more than 2 billion users globally. And the 2 newly deployed spacecraft are the first of an updated Batch 3 design, incorporating new technological advances over the original first-generation satellites. A further 10 of the improved Galileos are still to be launched, and work's already underway developing a new second generation of navigation satellites. The Galileo's second generation, or 2G2 satellites, will be the most advanced navigation satellites ever built. They'll use electric propulsion systems instead of the existing chemical thrusters, and they'll be fully reconfigurable in order to meet new tasks as the need arises. The first of them are due to be launched in 2024. This report from ESA TV.
Europe's Galileo constellation is the most precise satellite navigation system in the world, delivering meter-scale accuracy. Its signals let us find our way on foot, by car, even in boats and aircraft. So how do Galileo satellites, thousands of kilometres away, tell you exactly where you are? Simply being so far away is part of the answer. The satellites fly in 3 orbital planes, 23,222 kilometres above Earth's surface. Anywhere on our planet, at least 4 satellites are visible at any time, the minimum needed for positioning. Each satellite emits a radio wave containing its transmission time and the satellite's own position. Because radio travels at light speed, the signal's distance of travel is measured from the difference between the signal timecode and the time the receiver picked it up. It's like working out how far you are from a thunderstorm by counting the seconds between a lightning flash and its slower thunder crack. Time is converted into distance. For useful positioning, this timing must be accurate to a few billionths of a second, the time it takes for light to travel 30 centimetres. Combine distance measurements from multiple satellites simultaneously, and your position is pinpointed. A minimum of 4 satellites is needed, 3 to fix the user's latitude, longitude, and altitude, and a 4th to double-check time. Your receiver is smart. It knows the expected locations of the satellites to cut signal acquisition time from minutes to a few seconds. And as Galileo signals are very faint, equivalent to a 60-watt light bulb shone down from space, they are based on complex codes identifying each separate satellite. The receiver has copies of all these codes, so can make its own full-scale replicas of faint original signals for calculation purposes. These are used to calculate your final navigational fix, boosting our economy and quality of life by letting everyone, everywhere, find our way.
This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study shows that you're 3.4 times more likely to catch COVID-19 if it's been 6 months or more since your last jab. The findings, reported in the New England Journal of Medicine, showed that this trend was consistent across both ages and vaccines. While death rates were low for all vaccinated groups, mortality rates increased for older people who got the Pfizer jab in the early months. The study also found that the Moderna vaccine's protection was sustained in regard to deaths. The authors say their work adds to the growing evidence supporting the third booster shot, especially for older patients who had the Pfizer vaccine. Australia is about to begin issuing third doses to patients 3 months after their second jab. Meanwhile, Israel and Germany have moved on to giving their citizens a fourth jab in order to try and keep the new Omicron variant at bay. Phase 3 trials of the Novavax COVID-19 vaccine are showing that it's 90.4% effective at preventing COVID-19 infection. The trials saw Novavax given to 20,000 people, with a further 10,000 receiving a placebo. Over 3 months, 14 vaccinated participants tested positive to COVID-19 compared to 77 placebo participants. A report in the New England Journal of Medicine found that 10 moderate and 4 severe cases occurred, all in the placebo group. Of the COVID-19 cases that were sequenced, 4 in 5 were of a variant of interest or of a variant of concern. Almost 5.5 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be double that amount, with almost 300 million confirmed cases. The Russian town of Verkhoyansk has set a new Arctic temperature record, reaching a sweltering 38 degrees Celsius. That's over 100 degrees on the old Fahrenheit scale. The World Meteorological Organization says the record high temperature was recorded back on June the 20th, 2020, during an exceptional and prolonged Siberian heatwave. Average temperatures across the Arctic Siberia hit around 10 degrees Celsius at one point during that summer, leading to major ice loss in the region. A new study has found that the western honeybee may have originated in Asia. The findings, reported in the journal Science Advances, indicate the bees expanded independently into Africa and Europe, creating 7 separate geographical and genetically distinct evolutionary lineages, all of which are traceable back to Western Asia. The western honeybee is used for crop pollination and honey production throughout most of the world, and has developed a remarkable capacity for surviving in vastly different environments. Scientists sequenced 251 genomes from 18 subspecies of the honeybee's native range and used this data to reconstruct their origin and pattern of dispersal. The sequencing also led to the discovery of 2 distinct lineages, one in Egypt, the other in Madagascar. Medical experts are warning against COVID-19 vaccine detoxes that some people inaccurately claim can remove the effects of vaccinations in people who have changed their mind after getting jabbed. Anti-vaxxers and fraudsters have been pushing a range of so-called treatments ranging from borax baths to cupping, none of which work. Tim Mendham from Australian Skeptics says, despite all the claims, you simply can't unring a bell.
So basically this is the idea that once you've been vaccinated for COVID, you can actually undo the vaccination with various treatments, such things as going into a bath with baking soda, Epsom salts and borax as a cleaning agent to actually detox the vax, as they say. The issue here is that people have succumbed, if you like, anti-vaxxers have actually succumbed to having a vaccination. I would presume primarily so they can do things that unvaccinated people can't and go places. And then they decide that once they've had that and had that proof of being vaccinated, that they can then undo the evil effects of the vaccine. They can't, and it won't, basically. And certainly having a bath in baking soda and borax is not particularly a good idea, actually. Just one of those silly theories that's been going around. I mean, the weird thing is, it's, as I say, it's turning from anti-vax to taking a vax and then trying to get rid of the vax, and sort of, it's just sad and extreme, but it's one of many things people keep trying to say. You can undo the vaccination where you can't. Once it's in, it's in. You can't get it out again.
They really need a vax and a good lie down, don't they?
I think they really do need a vax and good lie down, yes. That'd be good advice.
That's Tim Indham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.